everyone, welcome to this session where we will learn the concept of AC and DC. While AC stands for alternating current, DC stands for direct current. Now, mobile batteries, clock and TV remote batteries, button cell batteries in watches, car batteries are all examples of DC sources. However, the power supply available in our homes and industries are from AC sources. From the illustration here, you can see a typical DC source. You can see that the current is flowing in a single direction. Here the electron flow is indicated from the negative direction to the positive direction, which is to imply the current will be in the opposite direction, but it will always flow in the same direction. However, alternating current behaves differently. It changes its direction at regular intervals. Now here you can see a typical AC waveform. You can see that the AC current is alternating between the positive and negative direction. And you may also notice that it is temporarily going through a 0 point, a point where its magnitude is becoming 0. And in DC, you can see that it is unidirectional. Now, let us try and understand alternating current a little further. Now, if you had to understand the motion of a single electron, it would move in this direction for some time, and then it would move in this direction. Again, it would move in this direction, and then again this direction. So you can see that a single electron is changing its direction at regular intervals. Now, this would become one cycle, this is another cycle, and it goes on and on. If you had to understand with the concept of a circuit, you had a bulb connected this way, say in a circuit, and you had an AC, this is powered by an AC source, the electrons would start moving in this direction at first, and after some time it would reverse the direction and start moving this way. But every time it would change the direction, it would temporarily stop. That is, it would move this way, stop, then move this way, stop again, move this way, stop again. So every time these electrons stop, the current does not flow, which is to say that the filament will start cooling a little bit. Now, this explains why the light or bulb would flicker. However, we notice that our human eye cannot notice this flickering. Now, this is because of a phenomenon called as persistence of vision. An image stays in a human brain for 1/15 of a second. So, if any image had to replace the existing one within that period, it would still give the illusion of continuity to a human being. However, this phenomenon would be evident to you if you had to take the continuous photographs of your tube light, or maybe even a video, and then watch for yourself. Now, there is another important concept we must know in this regard, the concept of frequency. Now, like I said, every time the electron goes this way and then resets its position back, this would be called a cycle. Now, I'm sure we've always heard of the frequency as being mentioned as 50 Hz in India and another 60 Hz in the US. Now, what this means is that the current goes through 50 such cycles in 1 second. So when I say 50 Hz, it means 50 cycles in 1 second. Or in other words, you can say that the current is changing direction 100 times. So if you had to take the case of a single electron, it changes 100 times in 1 second if your frequency is mentioned as 50 hertz. So in the case of 60 hertz, it would mean that a single electron or current alternates direction 120 times in 1 second, or it completes half of this, so 60 cycles in 1 second. So now we are brought to the big question: why do we prefer AC as against DC? So why exactly do we need to use AC? In order to power our homes, we need the power to be carried from the generation station to our homes, which is a long distance. Now we know that power loss is given by I square R. In order to ensure that the power loss is a minimum when transmitting over large distances, it is important that we keep either a low current or a low resistance. A low resistance would imply thicker wires because it demands a greater cross-sectional area. So that is not an option. Thus, we are left with only other option, which is to reduce the current. Now, reducing the current would mean stepping up the voltage. Now, AC is a good solution to this problem. Now, using an AC instrument called as a transformer, it is possible for us to step up voltage at the generation and transmission end and also step down voltage at the consumer end or at the household level. So AC basically allows us to reduce losses when transmitting the voltage or the power over long distances. Now, another question that crops up in our minds is why we cannot use high voltage DC as against AC. Well, there are two reasons for that. One, the plant cost is comparatively lesser for AC systems, and two, conversion from AC through rectifiers is much easier when compared to the conversion of DC to AC.